What's going on, everybody? Welcome back to another Granularity.ai tutorial. So, today we are going to kind of shift away just for a little bit from any type of AI concepts and conversations. And we're going to kind of get into something a bit more, I don't want to say nuanced, but something that's a bit less talked about from what I'm seeing. And that is quantum computing. Uh, I know there's a whole lot of talk when it comes to AI right now, especially with MCP, also known as Model Context Protocol, being involved in AI development now, as well as GPT-4o coming out with their image generation, which I think I might talk about that in the next video. I just think quantum isn't getting as much love and as much publicity as it should, right? We are in a time, in a very interesting time, where we have two highly important, um, two highly important pieces of technology are being developed in tandem at the same time. One is large language models, aka AI as we know it, and quantum computing, especially with companies like IBM, Google, NVIDIA coming up with these quantum chips and quantum software packages, stuff like that. The world of technology as we know it is shifting quickly with these different developments. And again, I just think one of those things that we're not paying attention to enough is the world of quantum. I think it's not getting its well-deserved praises, at least not yet. And I think, at least I want to be one of the first people to kind of make sure that it gets its well-deserved praises. Quantum or a mixture of classical and quantum computing has been used for a while. Maybe not to the same degree as like, what NVIDIA or Google uses their uh, quantum chips for, but one industry where quantum computing is incorporated into for a while, I think, or a mix of it for a while, has been in investment banking, has been in hedge funds, financial sectors. Quantum computing with a little bit of classical computing has definitely been incorporated. Even in chemistry, even in machine learning and optimization, quantum has been incorporated to a large degree, to a degree that most people don't even recognize. Most people focus a lot on like the decision trees and the linear regression models, logistic regression models, support vector machines. I think it's PCM. I think it's PCM. That's used for feature engineering stuff like that when it comes to machine learning algorithms. But a lot of people don't talk enough about quantum. And frankly, I am heartbroken that it's not getting as much love as it should. So today we are going to develop a quantum portfolio optimization algorithm or logic. This is pretty, most people when they are getting into uh, in the financial space, in the investment banking space, there's something called a quant, a job role called a quant. Basically, it's just a data scientist who is very well versed in financial engineering, right? Very well versed in financial markets, very well versed in portfolio management, uh, hedge fund techniques, algorithms that uh, you can incorporate into investments. This individual is just very well versed in stuff like that. We won't get, I'm not an investment banker. I've never been an investment banker. Um, I should probably say that this is not financial advice. If you are listening or watching this on YouTube, make sure you seek a financial advisor if you do want um, financial advice for anything. Don't take my word for it. Please seek out financial help, financial advisory, stuff like that. I think most videos that talk about investments, they usually want to make that stipulation and add that into the fine print. So I did too. When developing this logic, we're going to use something called Qiskit, which is by IBM. Qiskit is an open source Python framework for designing, simulating, and running quantum circuits on IBM's quantum hardware. It provides tools for quantum circuit construction, high performance simulation, and executing algorithms in fields like optimization, machine learning, and chemistry. Key components include Qiskit Terra for circuit building, Qiskit Air for simulation, and Qiskit IBM Quantum for accessing real quantum computers. We will be using Qiskit Air, I think it's pronounced, for this as well. And I think that's one of the packages we're going to be using. And I think Qiskit IBM Quantum is obviously a package that we'll be using in this too. Um, there are multiple different quantum packages out there. I just think Qiskit is probably the most popular out of all of them, just because IBM has been popular for years and years and years and years and years. But we're going to be using a mixture of Qiskit with Y Finance, um, and also including the GPT model to translate the results we get, right? Because the results can be kind of hard to read, I will admit. But maybe let's see how if an LLM can maybe incorporate with some help to understanding these results. You don't need to be well versed in quantum mechanics or quantum computing to use a quantum package. I think a very minimal, I think if you can understand, if it's one thing when it comes to quantum that you should understand, I'm not going to explain it in this, is the topic of Schrodinger's cat, right? Where, at least in the quantum space and quantum conversations, um, the cat can be dead or alive, right? And with that, it's basically equating that a result from quantum computing or while it's computing is operating in a superposition, right? Where it's both a one and a zero. Same thing with Schrodinger's cat. It's operating in a superposition where it's both a dead or alive, right? So quantum computing, Schrodinger's cat, and superposition are kind of the main concepts you should kind of learn about. Again, I'm not a quantum scientist or I'm not versed in quantum mechanics, but I do understand the concept at a bare level of superposition and the Schrodinger's cat equation or concept or whatever it is to kind of explain, or metaphor, I think, to kind of explain um, quantum mechanics to a small degree. If this sounds like something that you're interested in, if this sounds like something you're curious about, please make sure you subscribe. Based on your likes, based on your subscriptions, um, based on your dislikes as well, tells us whether this type of content was beneficial for you or whether this type of content was useless to you, right? Then we're operating off of those metrics to determine um, which content pieces meet your liking. So please make sure you like, please make sure you dislike even, please make sure you subscribe, hit that subscribe button, smash that subscribe button, whatever content creators say these days. Make sure you comment, leave suggestions, leave feedback so that we can give you the best content that you deserve. With that being said, let's jump in. What's going on, guys? Welcome back. Let's make sure we jump right into the code and let's get going. So, as you can see, there's already a bunch of packages installed, NumPy, Pandas, Matplot. Some of these we will need, some of these we won't need, but like I said, through trial and error, you kind of just play with a bunch of different packages and see what works and what doesn't. But I pretty much boiled it down, at least, to needing NumPy, Pandas, DateTime, and Y Finance and the Qiskit packages. The Penny Lane is also another type of quantum computing package that we didn't use. But I think when I was doing my research in terms of which one was better, um, the Qiskit one from IBM came out on top. Penny Lane is a cross platform um, using quantum machine learning, but the IBM packages came out better in the long run when it came to, in comparison, when it came to which one to use and which one not to use. So you can remove these if you want. I'm not going to try to remove them now, just for the sake of time. But anyways, so we're going to kind of run all these real quick. Give it some time. And then we're going to jump right into the environment package. You can find the code in our GitHub, and I'll remove some of these packages to make sure it doesn't run as long. And you guys won't have to worry about kind of trying to figure out what to use. And then we're going to add our OpenAI key here. Get pass. I forgot to import OS and import get pass or from get pass import get pass. Okay, let's try this again. Beautiful. Nice. Cool. So now we are going to add our API to get the Y Finance market data. So we want the close as well as the adjusted close when it comes to market. Again, you can also add opening. Personally, I don't really care for the opening prices. Don't really matter. I think I believe it does matter for the closing prices and what they were in the end when you're trying to determine or trying to predict which stocks will perform the best, or which stocks to keep in your portfolio, or which ones to add. So we're only using the adjusted close or just the close columns from Y Finance. Now, if you're not familiar with Y Finance, it's basically a database that has all the stock data, NASDAQ, S&P, I think Dow is involved in that. All stock data, at least pertaining to the US, within it. Very, very simple API that you can use to pull different companies, stuff like that. You add the ticker in it, Apple, Amazon, whatever it may be, and it can pull that information for you. I will be copy and pasting a lot of this code just for the sake of time. I think the only one that I might write is the is the LLM one, but we'll see. We'll kind of check that out and see if we do want to write it out or not. So let's keep going. So once we've included the API for the Y Finance piece to extract that financial information or stock information, we then want to add the actual quadratic program to our code. So here's the formulation that we want. Nice. And I have my notes here to kind of dictate kind of what's going on here, just so I can remember off the bat. So number one, this function here creates a quadratic program, a formulation for quantum computers, sets up binary variables for each asset, builds the objective function that balance returns. This is important. This right here, I think it's this one here for the balancing of returns. And then the budget constraint is also pretty important. Um, Add a constraint that exactly budgets the number of assets that must be selected. So we're going to run this. Cool. And then here's where we actually apply the algorithm solution. Boom. The, what is this? QAOA, I guess, QOA. I don't know how you want to say it, or if it is even needs to be said. But this is where we kind of add an optimizer, provide an optimizer. And in this, we're using the quantum approximate optimization algorithm, which is a hybrid between quantum and classical computing algorithms being used today. We're adding a sampler, or it creates a sampler to run the quantum circuits, and then sets up a cobbler as the, I think sets up cobbler. I think that's another quantum package, I believe, or not a quantum package. I'm sorry, an optimizer. Um, to then as that classical computing optimization technique. And with that, combines eigen optimizer to solve the problem. I believe if you're not familiar with eigenvectors, from what I remember, it is a linear algebra concept. I believe that is a linear algebra concept that involves matrices and matrices optimization. I believe um, eigenvectors, superposition, quantum computing, definitely stuff to research. Eigenvectors are pretty important even in machine learning. Highly recommend looking into that. So with those things combined creates the quantum algorithm solution we're creating here. So we create this and run that. And then this is where we begin to use the LLM, the GPT LLM in this. So we want to do client OpenAI. We already have our API key inputted in the beginning, right, using getPass. And then we're going to do, what I've noticed, so the results that are going to be returned is binary, right? Binary meaning here's the stocks that would be good for your portfolio, here's the ones that would not, in a 1-0 kind of format. And then it has an optimal portfolio objective value, which from when I was reading about it can be kind of confusing to learn about. But I'm gonna try to translate it in what I've learned and the best I can in this video. If anyone else is a investment banker or a quant or knows way more than I do about this, please chime in the comments. Tell me where I went wrong. Correct me. Maybe even you could be featured in a video and we can talk and you can kind of present some projects and educate everyone else on these topics. Because again, I've never been an investment banker. I have been into stocks for a while. I have been in the past known to create like very small using the R language, very small like statistical uh, linear or logistic regression algorithms to predict certain uh, company ticker momentums. I think I did one for Starbucks in the past and Amazon and stuff like that. So I do like playing with financial data and um, predictive capability to see which stocks to pick and which ones to add to my portfolio, which ones not. Again, repeating, this is not an investment advice. Please do your due diligence when you are researching these stocks. Do not treat investing as gambling unless you're a day trader and unless you want to kind of get into that. Do not treat investing as gambling. I'm looking out for you guys when I tell you, make sure you look at investing as long-term savings. Not trying to be, again, for more advice, go to a financial advisor. This is just me providing some big brother advice, I guess, however you want to call it. But anyways, moving on, we've established our client OpenAI API. So then we're going to do def translate result. And we want to do result text, comma, target language, just saying which language you want it in. I think we don't really need this. I don't know why I inputted this in the first place. I think I was experimenting with different languages at first. Maybe that's why. but who knows? I can't remember. Response equals client response. Now, if you do need more information on the OpenAI API documentation, it changes all the time. Not all the time, but frequently. Highly recommend making sure you're keeping up with it, as because right, the AI world as we know it is changing faster and faster day by day. So make sure you keep up with it. Make sure you stay abreast to kind of what's going on out here to make sure that you can remain aware. Now, I have a prompt already that I created in the past that I'm just going to use here again, and then I'm going to read it to you guys. Maybe you can use the same prompt if you would like. So I have, as a financial engineer using Qiskit for portfolio optimization, I am to maximize returns. Based on the results we get, please assess whether this portfolio effectively maximizes return. Keep the response concise. This is basically, in a way, assigning a persona, assigning a job that basically it acting as an agent for these results, right? And kind of deciphering these results and translating these results. This isn't an actual AI agent. I want to make sure I make that distinction. If you want to know more about AI agents, I have plenty of videos from the past. I don't know how many videos I have now, educating people on AI agents. And I think I might create a separate playlist for it. Uh, but yeah, make sure you take a look at those videos from the past. Educate yourself on AI agents because it's still extremely important to this day. But again, this is not an AI agent. Let's keep going. Return response. Just creating this function again to translate the results we get from our quantum logic response. Cool. And now here we are taking the larger portion of the code here, the main execution, where I've already selected a few different stocks to choose from. I might change this up a little bit and make it interesting. Um, but let's say we do Amazon, and let's change this from Amazon to let's do KB Homes, KBH, and then so we have technology. Technology is Amazon. Let's just say that's technology, e-commerce, what are you going to call it? We have KBH, which is a home construction company, I think. Let's add mRNA, Moderna, so pharmaceutical. Um, and then, ooh, this one might be nice. Keep it interesting. Uh, Palantir, PLTR. And then let's add one more. Um, What's a good one? Um, let's do LAZR, which I think does sonar technologies. I think. These are actual stocks I have in my own portfolio and that I kind of played with. Again, this is not financial advice. I'm not providing any financial advice here. This is just us kind of playing with me using uh, real world stocks that I have in my own portfolio just to see, based off of these tickers, what it kind of recommends to keep and not keep. Again, one thing I want to state also, don't take this as a don't take this as an insurity, like whatever output comes out of here as an insurity. Again, make sure you do your due diligence. Make sure you do your research on these companies whenever you're investing. Do not take models whether AI, whether quantum, financial models, do not take them 100% serious. Always leave room for a good level of risk. Always leave room for a good level of skepticism, because frankly, models can be wrong. They're not 100% accurate. The stock market doesn't just operate off of cost and money. It operates off of customer sentiment. It operates off of natural disasters. It operates off of firing and hiring, layoffs and mass hires. It operates off of global events, climate events. Make sure you do your due diligence and your research when putting money into the stock market. Now, with that being said, let's run it and see what happens. This does take a bit of time. We have what, 5 different stocks? I think the max that I would put in here is probably 10. Um, if this so far has interested you, if I have made it exciting and interesting, please make sure you subscribe. Please make sure you smash that subscribe button, smash that like button. Feel free to dislike if you would like. If you do choose to dislike, make sure you just provide some type of context as to why, some feedback, some feedback, comments that can maybe help us provide better content for you. The subscriptions and the likes and the dislikes is what we run off of when it comes to feedback, to make sure um, that we're providing what you want. With that being said, sorry, I know I'm holding up time, making it suspenseful. Let's run it. This does take some time. Cool. So let's give it a few minutes. We have a error. OpenAI response. I think I spelled response wrong. Da, 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 da. Return response. Let's see what this error might be. Could it be the spelling? Possibly. Let's check that first. No, I don't know what it could be. Let's do some reading for a second. I see. I see. I see. Response says. Now let's run it and see what happens. There we go. Like I said, this does kind of take a while. The limit that I would add to the tickers, I've added like 23 different tickers to it, and it does kind of take some time. Before we get into it, let me finish what I'm saying. I know you're excited. Uh, um, there is like, I've added 23 different tickers into this, and it takes a long time, more than an hour, right? I think the limit for this, preferably for me, 10. Because you also got to think, with 23 different tickers, it's also using Y Finance to load in a plethora amount of data. It could take a while. The API can get overloaded and it can take a while. I think 10 is the optimal amount of tickers you want to add to this to make sure it runs smoothly. I wouldn't go over 10. You could try, be my guest. Let me know if it works, if it doesn't work in the comments. But anyways, let's jump to the results. So as you can see, we have, again, it goes off of a binary kind of result here where, hold on a sec. Yeah, goes off of a binary result here where we have Amazon 1, KBH 1, Moderna 0, Palantir 0, Laser 1. In this, what it's saying is, in terms of the stocks to select and the stocks not to select, it's saying Amazon is definitely one to make sure this small portfolio here um, is optimal, right? Amazon is one you want to select. KBH is one you want to select. Moderna is a no. Palantir is a no. And Laser is a no. I think this is Luminous. I don't think it's called Laser, but I don't remember. I don't remember what the company is. But LAZR is a no. With a optimal portfolio objective value of negative 0.6. Now, I don't want you to get scared of this number because the numeric results mean different things depending on your strategy. So this is using MS Copilot to explain this, and this is not a Copilot sponsored video, just FYI. But let's kind of take a look. So I asked it, what if my result is optimal portfolio objective value negative 0.607, blah, blah, blah. So, yeah, a negative portfolio objective value, such as negative, suggests that your objective function is designed to reward lower values under specific conditions. Yeah. Let's break down how to interpret this. What a negative value might indicate: if your model minimizes risk, a negative value might indicate significant optimization success, achieving lower risk compared to benchmarks or alternative portfolios. If the function incorporates returns and penalties, the negative result could imply that penalties outweigh potential returns, reflecting a high risk-averse strategy. A negative objective value can be advantageous in certain optimization setups, especially when minimizing risk or penalizing volatility. So what I'm reading this as is the greater the negative output, the greater the negative result, the more advantageous in certain optimization setups, especially when minimizing risk. So the more negative result, the better you are at minimizing risk. Its interpretation depends on your objective function, portfolio constraints, and benchmarks. If you would like to explore additional scenarios or refine strategy, I can help guide the process. Let's kind of build on this a bit more. I want to refine my strategy. Let's see. Let's see what it kind of gives. I'm not going to read all this. I'm kind of just going to go straight to the conclusion. Refining your portfolio strategy is a great move. Here's how you can improve it: analyze objective function, clarity goals, and corporate benchmarks, diversify example relations, stress testing, blah, 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 blah. Next steps: you can start by modifying your current model's parameters and testing a few alternative scenarios, perhaps introducing new constraints or exploring different asset combinations. Again, depending on the combination of tickers you add can make or break your optimization score. Again, what we're realizing is if the optimization score is in the negative, right, we are minimizing risk or penalizing volatility, right? What happens? What does it mean if the optimization score is positive? If the optimization result is a positive value, its meaning depending on the objective function and context. Positive value in maximizing objective functions. If your objective function is designed to maximize returns, a positive value reflects the expected or achieved return of the portfolio. A higher positive value generally indicates better performance in terms of return. So if you're looking to maximize, if you're looking to minimize risk, a negative value is beneficial for you. If you're looking to maximize returns, where is it? If you're looking to maximize returns, a higher positive value generally indicates better performance in terms of return. For objective like maximizing the Sharpe ratio, a positive value signifies the portfolio's return exceeds the risk-free rate relative to its risk, implying a favorable risk-reward balance. Conclusion: a positive optimization result generally represents either favorable returns or the degree to which your optimization goals are achieved. To fully interpret its meaning, consider the definition of your objective function, comparisons to benchmarks and alternative portfolios, the specific role of constraints or penalties in your model. So basically, again, if you want to minimize risk, a negative result is good. If you want to maximize returns, a positive result is good. Um, Again, it depends on your strategy in general, right? Maximize returns could be more risky, right? Uh, there's the concept of high risk always equates to high reward. Um, Low risk doesn't necessarily equate to high reward, but it does equate to steady outcomes. So, anyways, this isn't an MS Copilot plug. This is part of, if you have a Samsung laptop PC, I think Copilot comes with it now, which is pretty cool. But anyways, so that's a great way to use AI in kind of determining your strategy and what you want to do. But we also have AI incorporated, or the GPT model incorporated into our own logic here, which it was able to translate the results for us, and we get to assess if the portfolio effectively minimizes risk. Consider blah 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 holding indicates a focus on tech, housing, and autonomous sectors. Ensure these sectors align with your returns to risk. Total objective value. The objective value of zero suggests the objective value of negative 0.6078 suggests inefficiencies or limitations in achieving expected returns. Again, we in this portfolio that we've given it, we are not expecting returns. Instead, right, we want to minimize risk, right? Because like we just learned from Copilot, if it's a negative output, the less risk we acquire, right? Because negative output equates to minimizing risk. Uh, Generally, a value closer to zero or positive is more favorable. Risk assessment. Evaluate correlations could indicate higher risk, some weighting. Market conditions. Consider whether market conditions favor blah. Again, this output is kind of messy from GPT-4o. I didn't add any different ways to pull the context out or the content out. I kind of just went with the bare bones of it. But again, if you want to make it cleaner, be my guest, take this code and do it as you will. But again, this is a great way. This is a great first project for anyone looking to be a quant, a data scientist, stuff of that nature, or a quant or a data scientist in the financial sector, and maybe do like financial engineering work. Again, I am not a financial analyst. I have never been a financial analyst, but I do play on the stock market here and there. I do like to develop algorithms that experiment and learn as well when it comes to financial education, financial literacy, stuff of that nature. I will say again, if you are looking to do something like this or looking to figure out how you can optimize your own portfolio, uh, maximize your returns in the stock market, or minimize the risk in your portfolio in the stock market, please seek financial advice, not from me, not from an AI algorithm, not from a quantum algorithm, but instead from a financial advisor first. Get a consultation, ask questions. Sometimes they're free, sometimes they're not, sometimes they cost a lot, sometimes they don't. All I ask is make sure you do your due diligence when you are investing. Investing should not be gambling unless you're a day trader and you're into that kind of stuff. I'm not, frankly. Don't treat investing like gambling. Treat it as a long-term savings account. Uh, if it's one advice I can give you that is financial advice, uh, even though I'm not a financial advisor, right? You don't have to take my advice. If you want a safe vehicle for your capital and your funds, index funds are a sure way to have a safe vehicle in generating returns on your capital. That and ETFs. I think ETFs are still popular. Index funds and ETFs, I believe, in my opinion, are a very sure way in making sure that you have a stock savings account that can continuously generate value for you. Again, I'm not a financial advisor. Um, Please seek financial advisory help if you are interested in investing or putting your money somewhere safe. If you enjoyed this kind of content, please make sure you like, please make sure you dislike, please make sure you smash that subscribe button. All I ask is that if you do decide to dislike, please leave comments, please leave feedback, please leave suggestions so that we can provide you the best type of content for you to view and see. Also, if there's any investment bankers out there, any type of quants out there, I would love to talk to you. I would love for us to have a discussion, a back and forth, I guess, on different scenarios you've seen when it comes to being in industry. What is the popular thing, the popular algorithms? What advice can you give to someone looking to do an internship as a quant? What first projects would recommend? Uh, I would love to have you on and kind of have a discussion, and maybe even you can show your own project. So please, if there's any quants out there, any investment bankers out there, um, make sure you yell at me in the comments, and or you can reach out to me through Instagram. Um, Granularity Analytics Instagram, or granularity.ai. I'll throw the username, I'll throw the Instagram into the description, and you guys can hit me up, or just anyone for that matter who's interested in kind of being a special guest on, and having a small discussion on anything AI and quantum. With that being said, bye bye.